Welcome back to AM. Joining me now is Dr. Bill Deese, Louisiana Tech Chemistry Department. Good morning.
How are you doing?
Good. Good to see you.
Well, it's good to be here.
What are we doing today? Now, I must admit, I've had no warning.
No warning.
Other than I've been given these
That's right.
little
and
goggles
in a little
to
bit,
wear.
we're going to light a flame in a minute, and we'll want to put our goggles on before we do
okay.
that. But tell me what's going on inside the flask here.
We're boiling water.
Boiling water, okay? And of course, down at the bottom of the flask, we can see gas bubbles forming.
Okay.
Do you have any idea what those gas bubbles are?
Not really.
Not really?
Well, one would assume that we would go, oh, okay, so that's air,
well,
but it's gas.
It's right. It looks just like air because it's a colorless gas.
Right.
And a lot of young people today will tell you that those are air bubbles.
Okay.
But they're not. Those are water bubbles. That's gaseous water. Okay. And so what we're doing here is we're changing liquid water into gaseous water.
Right.
Okay.
Gotcha.
And of course the bubbles first form down at the bottom. That's where the heat is.
Right. Okay.
All right. And so the formula for liquid water is H2O.
Right.
And the formula for gaseous water is H2O.
Okay.
Okay. So we have not changed the chemical composition
right,
of water.
of the water at all.
But it is a change. It's a change from a liquid phase to the gas phase.
Okay.
And we call that
Following
a physical.
you.
That's a physical change.
Right.
It's not a chemical change. Okay? If it were a chemical change, the formula or the composition would have changed.
Okay.
And so this is one thing I do in my classes and in workshops I do all over the north part of the state, showing science teachers things to do, to show the difference between a physical change and a chemical change. Okay. Now, can you see the fog coming out of the tube over here? It's easier to see on camera, I think.
Right.
Okay, what is that fog? Do you think that's a solid or a liquid or a gas?
A gas.
Okay, that's what everybody says. But that's not a gas. That is actually tiny droplets of liquid water. Okay. And so the gaseous water has gone up and gone through the copper tubing and cooled off and condensed back into a liquid water. And these are tiny, and anytime you see a fog there, you know that that's tiny droplets of liquid water, and that's what clouds are, and that's what fog is when we see on cool mornings. Because gaseous water is invisible, just like air is invisible. Okay,
so
pretty
we're
neat.
seeing
now,
it. How about that?
This is the temperature of boiling water is 212 Fahrenheit or 100 degrees Celsius. Okay, and it's cooled off a lot by the time it gets out here, so I can hold my hand there for several seconds. Now, if I held it there long enough, it would hurt. Okay,
it would be hot.
But you can see, and I can put this piece of paper in there, and all it does is get wet. Okay, but what we're going to do here, and this is where we need to put our goggles on.
Goggle time.
Okay. They look good on you, too.
Oh, do they? Oh, you're so kind. He's just trying to be nice now.
And so if you'll strike that match.
Oh, good. Okay.
I'll get you to light this burner for me.
Okay.
Okay. All right.
There we go.
Now, what I'm going to do with this burner is warm up. See why we have our goggles on?
Right. I do see why.
This was working perfectly a while ago. Okay. We're going to warm up these copper coils.
All right.
Okay. And as we warm the copper coils up, that's going to prevent the gaseous water
from cooling off.
Okay? And so gradually we should see the steam plume change. Okay?
All right.
Now, gaseous water is called steam, right?
Right.
If it's at the boiling point.
Okay.
Okay, 100 degrees. But if you heat gaseous water, or if you heat steam up above 100 degrees Celsius, we call that superheated steam. Now, can you see any of the steam plume at all?
No, you can't.
Okay, the fog has disappeared.
Right.
And that's because now the only thing coming out of the tube
is the gas.
Is the water gas or the water vapor, and it's invisible. Okay.
How about
now,
that?
Superheated steam is very, very dangerous. Okay.
Okay.
And so we would never put our hand in front of it right now.
Okay.
Okay.
Because it would be very
hot. It would burn us very badly.
Okay.
And so I'm going to stick this piece of paper in there. I think it's probably warm enough now. And it's not quite as hot as I want it. Okay.
It's pretty hot.
It's
You're doing
pretty
a job
hot.
on those little coils
That's
there,
right.
aren't you?
Okay. But notice.
Oh, look.
Okay.
Oh, I see.
Yeah. All right, it's warming up
Can
good
the camera,
now.
yes, it is. Can the camera
Notice
pick that up?
that piece of paper has become charred.
Right.
All right. So it's very hot.
Very.
Okay. Now, another thing, if we've got it hot enough, is we can light a match. Have you ever lit a match by sticking it in water?
No.
Okay. Let's see if we can light this match by sticking it in water.
Sure. How about that?
Okay. And so that shows you how hot that superheated steam is. and how you have to really be careful with it. Okay?
Definitely.
And so today, you know, we were doing what we call a physical change. Okay?
How about that?
Yeah.
I'm
and
impressed.
So, yeah, you've probably heard the term superheated steam before, and not everyone realizes what that is, but it's water vapor that's been raised above the boiling point, above 100 degrees Celsius.
What can I say? It's
Well,
always a pleasure having you on the show. I can now take these off.
That's right.
And we've all learned something today.
Well, good. It's
Bill,
a lot of
thanks
fun
for-
coming over.
Well, thanks for being here. We sure appreciate it. We'll be back in just a moment with more AM, so don't go away.